Okay, good morning, students. So today we are going to discuss the next topic, that is dual nature of matter, dual nature of radiation and matter. Okay, so in this chapter we will deal with what do you mean by photoelectric effect. So the main concept of this lesson is learning the photoelectric effect. Okay, so photoelectric effect, different types of photo emissions we are learning here. Einstein's experimental observation we are discussing. Okay, so again this topic is consisting of the numericals. So we are discussing the numericals also at the end. So let us begin with the class with the introduction of the chapter. Yes, so here, before going to understand what is photoelectric effect, here we need to understand some of the terms related to the photoelectric emissions. Okay, photoelectric effect. So what is photoelectric effect study ಮಾಡಬೇಕಾದ್ರೆ first ನಮಗೆ what do you mean by free electrons ಅಂದ್ರೆ ಗೊತ್ತಿರಬೇಕು students. So what is free electrons? Free electrons in metals, the electrons in the outer shells are loosely bound to the atoms. Hence, they are free to move easily within the metal surface, but cannot leave the metal surface. Such electrons are called as what? Free electrons. So, what do you mean by the free electrons here? As you know that the metals consist of the free electrons. So metals ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, electrons are loosely bounded. So these loosely bounded electrons, whatever it is there, they are free to move easily. So if you consider any of the atom, the outermost shell of the atoms consist of the electrons. So e electrons ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, these electrons are loosely bounded. When these electrons are loosely bounded, here these electrons will try to come out of the surface with some of the external energies given to it. So this is called as what? These electrons are called as what? Free electrons anta ಹೇಳ್ತಾರೆ. The loosely bounded electrons to the atom is called as what? Free electrons. So in this type, here, after understanding what is free electron, here we need to understand what do you mean by electron emission. So see what is electron emission here, students. The minimum amount of energy required by an electron to just escape from the metal surface is known as what? Okay, this is not electron emission definition. So this is a work function definition. By mistake here it is written. So here electron emission andre noda, electron emission, it is nothing but it is the process. So it is the process of emission of free electrons. Emission of free electrons from the metal surface is called as what? Electron emission anta ಹೇಳ್ತಾರೆ. ಹೌದಾ? So simple term, electron emission. So what is happening here? That is the electrons are coming out of the metal surface is called as what? Electron emission anta ಹೇಳ್ತೀವಿ. ಗೊತ್ತಾಯಿದೆಯಾ electron emission ಅಂದ್ರೆ? So in the electron emission, students, we have some 3 types of electron emission. So what are the 3 types of the electron emission? Nodana? Here one is there, that is the thermionic emission, field emission, and the third one is the photoelectric emission, and the fourth one is the secondary emission. Okay, so total we have 4 types of electron emission. So what do you mean by electron emission, students? That is the emission of the electron from the metal surface is known as the electron emission. So in the electron emission, we have total 4 types of electron emission. One is thermionic electron emission. Second one is field electron emission. Third one is secondary electron emission. And the fourth one is photoelectric emission. Yes. So as the term indicates, thermionic. So what do you mean by the thermionic emission? So thermal andre enu namge gottide. Thermal andre heat anta. Okay. So when the heat energy is incident on the metal surface, here the electrons will come out of the surface. That phenomena is called as what? Thermionic emission anta ಹೇಳ್ತಾರೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? What is thermionic emission? Yes, thermionic emission is nothing but here the electrons are emitted from the metal surface with the help of the thermal energy. With the help of the thermal energy and with the help of the heat energy anta ಹೇಳ್ಬೋದು. Yes. Is it clear? Free electrons, electron emission, thermionic emission. All the three definitions are clear to you. This lesson is 99% it is theory only. Okay. So electron emission, thermionic emission. So let's go for the second type of emission, students. That is, it is called as the field emission. It is called field emission. So we may discuss. So as the term indicates, field emission antandre, when the metal surface is subjected for the strong electric field, when the metal surfaces are subjected for the strong electric field, here whatever the emission of the electrons we are observing by that, that is called as what? Field or cold cathode emission. Yes, what do you mean by field emission? Whenever there is a process of emission of the electrons from the metal surface, when strong electric field is given to the metal surface. So this is the electric field. So when this strong electric field is given to the metal surface, here what will happen? The electrons will come out of the metal surface. So this phenomena is called as what? Field or cold cathode emission ಅಂತ ಹೇಳ್ತಾರೆ. Yes. So ಯಾವುದೇ ರೀತಿಯಾದಂತ electron emission ಇದೆ students, that you remember here, it depends on the nature of the substance. It depends on the nature of the substance. It depends on the strength of the magnetic field. So field emission alli ಇದು ಎರಡು factor depend ಆಗುತ್ತೆ. It depends on the strength of the electric field. It depends on the nature of the material ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ಬೋದು. Okay. So if you come for the thermal or thermionic emission, here it depends on one thing, that is the nature. It depends on the nature of the substance, and also it depends on the temperature. So it depends on the nature of the substance and temperature. Field emission again it depends on the nature of the substance and it depends on the temperature. It depends on the, not temperature, it depends on the strength of the magnetic field. It depends on the magnetic field. Okay, so we have discussed definitions. Hope so it is clear to you. Going towards next definition, students, that is the photoelectric emission. This photoelectric emission. So see, photo means what? Photo means it is yes, we were discussing about the photoelectric. So in the photoelectric emission, so photo means what? Photo means that is light. Okay. So photoelectric emission means the electrons are emitted from the metal surface with the help of the suitable electromagnetic radiations. When the light falls on the metal surface, the electrons comes out of the metal surface. That phenomena is called as what? Photoelectric emission. Yes, hope so. Photoelectric emission is clear to everyone. Then next we can go for the that is secondary emission. So see what is secondary emission. Electrons are ejected from a metal surface by striking over its fast moving electrons. So secondary emission, in case of secondary emission, the electrons are ejected from the metal surface by striking over its fast moving electrons. So one electron bandil hit ಆಗ್ತಾ ಇದೆ ಬೇರೆ electron ಗೆ. So that time the outer surface electrons comes out of the metal surface. That is called as what? Secondary emission. So students, we have studied the 4 types of emission. Hotspot on Madrid. So we have discussed the 4 types of the emission, that is the thermionic emission, photoelectric emission, secondary emission, and the field emission. So yav emission heltira, that will be responsible for that phenomena. Thermionically, thermal heat energy. Photoelectrically, light. Field emissionally, electric field. Secondary emissionally, due to the collision of the electrons, fast moving electrons, the metal surface, the electrons will come out. That is called as the secondary emission. Okay. Yes. So this is regarding the introduction of the chapter, students. So here one question will come, why this metals are preferred for obtaining electron emission. So ella idral nav enanta helidvi, when the metal surface is, hauda. So yavade ನೀವು electron emission ತಗೊಂಡ್ರು ಕೂಡ we are specifying a metal surface. So why it is required for the metal surface? So see here, the metal surfaces, so the metals contains large number of free electrons. Metals ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ large number of free electrons will be there. Therefore, the metals are preferred for obtaining the electron emission. So electron emission ಗೆ metals ಅನ್ನ prefer ಮಾಡ್ತೀವಿ because more number of free electrons will be there for the metals. Okay. So this is regarding the introduction of the chapter, students. The next we will discuss what do you mean by the photoelectric effect. Hagadre photoelectric effect andre enanta nodana. And why this chapter is named as the dual nature of matter and radiation, that also we will see. Yes. So first, let us define the photoelectric effect. Then we can go for the experiment for the photoelectric effect. So see what is photoelectric effect. The phenomena of emission of photoelectrons from the surface of the metal. So photoelectric effect is nothing but photo emission. Now ಈಗಷ್ಟೇ ಏನು ನೋಡಿದ್ವಿ ಅದನ್ನೇ ಸ್ವಲ್ಪ elaborate ಮಾಡ್ತಾ ಇದೀವಿ sentence ಅನ್ನ. So see the phenomena of, it is some phenomena of the photoelectrons. ಇಲ್ಲಿ ಏನು electrons ಹೊರಗಡೆ ಬರುತ್ತೆ metal surface ಇಂದ, these electrons are called as what? Photoelectrons. ಈ electrons ಅನ್ನ photoelectrons ಅಂತ ಹೇಳ್ತಾರೆ. So the phenomena of emission of photoelectrons from the metal surface of a metal when a light beam of suitable frequency. So ಇಲ್ಲಿ ನಾವೇನ್ specify ಮಾಡ್ತಾ ಇದೀವಿ, ಇಲ್ಲೇನ್ light ಬೀಳ್ತಾ ಇದೆ, it should have some suitable frequency. So ಅದಕ್ಕೆ ಒಂದು particular frequency ಇರ್ಬೇಕಾಗತ್ತೆ. So when the suitable frequency of light incident on the metal surface, the electrons will come out of the surface. That is called as what? Photoelectric effect. That is called as the photoelectric effect. Yes. Hope so. What is photoelectric effect? That is clear to everyone. So photoelectric effect is nothing but when the suitable frequency of light falls on the metal surface, the electrons comes out of the metal surface. This phenomena is called as what? Photoelectric effect. Here, whatever the emitted electrons are there, illen horgade electrons barta ide, those electrons are called as what? Photoelectrons anta heltivi. And whatever the current you are getting due to this, that is called as the photoelectric current. So see here, students, what you need to remember, what is photoelectric effect? So andralle moor helta idivi, moor statement. Photoelectric effect, photoelectrons, photoelectric current. Okay. So what is photoelectric effect? The emission of the electrons from the metal surface when the light of suitable frequency falls on this. This is called as photoelectric effect. What is photoelectrons? Here, whatever the electrons are coming out of the metal surface is called as what? Photoelectrons. What is photoelectric current? Electrons barta ide. So idrinda ಏನ್ current ಸಿಗತ್ತೆ ನಮಗೆ, the current due to these photoelectrons are called as what? Photoelectric current. Okay, it is called as the photoelectric current. Hope so it is clear to everyone what is photoelectric effect. Yes. So here we specified one point, students, that is the light should be of suitable frequency. So ನಾವು ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದೀವಿ, ಏನ್ ಲೈಟ್ ಬೀಳ್ತಾ ಇದೆ, ಸೊ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಅನ್ನ ತಗೊಂಡು ಜಸ್ಟ್ ನಾವು ಸನ್ ರೇಡಿಯೇಷನ್ಸ್ ಎಕ್ಸ್ಪೋಸ್ ಮಾಡಿದ್ರೆ, it is not that the electrons will come out of the surface. So ಇಲ್ಲಿ ಏನ್ ಲೈಟ್ ಬೀಳ್ತಾ ಇದೆ, these lights should have some suitable frequency ಅಂತ ಹೇಳ್ಬೋದು. These lights should have some suitable frequency. So that minimum frequency, ಅದೇನ್ minimum ಒಂದು frequency ಬೇಕಾಗತ್ತೆ, that minimum frequency required for the photoelectric effect phenomena is called as what? Threshold frequency ಅಂತ ಹೇಳ್ತಾರೆ. That is called as what? Threshold frequency. Yes. So what is threshold frequency, students? That is the minimum frequency required for the photoelectric effect. That frequency is called as what? Photoelectric frequency. Sorry, threshold frequency. Okay. So similarly, threshold wavelength anta kuda helbodu, adu same barutte. The minimum wavelength required for the photoelectric effect is called as what? That is threshold wavelength. So what is threshold frequency or threshold wavelength? ಆ photoelectric effect ಆಗ್ಲಿಕ್ಕೆ ನಮ್ಗೆ minimum velocity, sorry, minimum frequency, minimum wavelength ಬೇಕಾಗಿದೆ. That is called as what? That minimum value is called as what? Threshold ಅಂತ ಹೇಳ್ತಾರೆ. That is called as the threshold. So threshold minimum frequency ಇದೆ, threshold frequency ಅಂತ ಹೇಳ್ತೀವಿ. Minimum wavelength ಇದ್ರೆ it is called as threshold wavelength ಅಂತ ಹೇಳ್ಬೋದು. Okay. Hope so this is clear to everyone. What is photoelectric effect? See, I told you already, it is completely a theory chapter. So many definitions will come in one class. So you need to remember all the definitions, students. So we started with electron emission. So electron emission in the start madidvi, the emission of the electrons from the metal surface is called as the electron emission. So in the electron emission, we have 4 types. That is thermionic, then photoelectric, then secondary emission, and the field emission. These are the 4 types of the emission. So after studying the electron emission, different types, we are coming for the next point, that is the photoelectric effect. So what is photoelectric effect? The phenomena of emission of photoelectrons from the metal surface when the light of suitable frequency falls on this. ಅದನ್ನ photoelectric effect ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲೇನ್ electrons ಸಿಗ್ತಾ ಇದೆ, that is called as photoelectrons. ಮತ್ತೆ ಇದರಿಂದ ಏನ್ ಕರೆಂಟ್ ಬರುತ್ತೆ, that is called as the photoelectric current. Okay. So after this, we are going to proceed with one more definition, then we will go for the experiment. So the next definition is, students, that is work function. Okay. Now we ಯಾವ್ದಾವ್ದು values ಅನ್ನ define ಮಾಡಿದ್ವಿ. We define the minimum wavelength ಅಂತ ಹೇಳಿದ್ವಿ. We define the minimum frequency ಅಂತ ಹೇಳಿದ್ವಿ. ಹಾಗಾದ್ರೆ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಅಂದ್ರೆ ಏನು? ಇಟ್ ಇಸ್ ದಿ ಮಿನಿಮಮ್ ಎನರ್ಜಿ. ಓಕೆ. ಸೊ ಈ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಆಗ್ಲಿಕ್ಕೆ, ದ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಶುಡ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. So some minimum energy is required for that. That minimum energy required for the photoelectric effect is called as what? Threshold frequency. Sorry, it is called as the work function anta ಹೇಳ್ತಾರೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? What is work function? Work function is nothing but it is the minimum energy required for the phenomena is called as the work function. Yes. So what you do, you just write the points. ಅಂದ್ರೆ ಯಾವ್ದಾವ್ definition ಹೇಳ್ತಾ ಹೋಗ್ತಾ ಇದೀವಿ, just ಅದನ್ನ points ಹಾಕಿ ಬರ್ದಿಡ್ತಾ ಇರಿ. ಅಂದ್ರೆ after the class, once if you just recall it, it will be good for you. Like electron emission ಹೇಳಿದ್ವಿ, ಇದ್ರಲ್ಲಿ 4 types discuss ಮಾಡಿದ್ವಿ. After that 4 types ಅಲ್ಲಿ ಏನೇನ್ difference ಇದೆ. Okay. Then after that photoelectric effect, then after that photoelectrons, then photoelectric current, then threshold frequency, threshold wavelength, and the work function. See, almost 1, 2, 3, 4, 5, 6, 7. 7 plus 4, that is total 11 points we have discussed. Yes. So make a note of it. If any doubt is there in the 11 points, please ask, students. Yes, if there is no doubt in this point. Next, let us go last. Okay, one formula you take down for the work function. So the work function is denoted by the letter W. It is given by H nu naught. Your work function is given by H nu naught, where nu naught is the threshold frequency. Nu naught is the threshold frequency, and it is also written as Hc divided by lambda naught. H is Planck's constant, C is velocity of light in the vacuum, lambda naught is the threshold wavelength. It is the threshold wavelength. Okay, threshold frequency, threshold wavelength. Yes. So therefore, the frequency is also written as C divided by lambda naught. So ನಿಮಗೆ ಏನು ನೆನಪಿರಬೇಕು, W is equal to the work function is equal to H into nu naught or Hc divided by lambda naught. Okay. So nu naught, lambda naught, threshold frequency, threshold wavelength. C is the velocity of light in the vacuum. Yes. So when you are doing this question, means with this formula, you remember here this is useful for the numerical solving. ಏನ್ ನೆನ್ಪಿಡಿ ಅಂತ ಅಂದ್ರೆ ಅಂದ್ರೆ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಅನ್ನ ನಮ್ಗೆ ಇಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ, ಬಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಇಟ್ ಇನ್ ಜೂಲ್ಸ್. ಹಾಗಾದ್ರೆ 1 electron volt is equal to, students, it is 1.6 into 10 raised to minus 19 joules. So 1 electron volt is equal to how much it is? 1.6 into 10 raised to minus 19 joules. Okay. So suppose the value is given as 4 electron volt. So to convert it into joules, what you need to do? You just need to multiply 1.6 into 10 raised to minus 19. Okay. So when you multiply this, you will convert the electron volt value in the joules anta helbodu. Yes. Okay. So now we are going for the Hertz experiment or the Hertz observation on the photoelectric effect. So what is Hertz effect or the Hertz observation? Let us discuss that. Okay. So what we were discussing, that is the Hertz observation or the Hertz experiment. So let us discuss the Hertz experiment. Yes. See. So this, according to this Heinrich Hertz, so what he will do, he will perform an experiment to investigate the photoelectric effect. Okay. So for that reason, he will conduct this experiment in 1887. So the experiment, what it is there, you can see that. Okay. So he is considering. So for the photoelectric effect, what he is going to do, he is going to take two evacuated chambers. So along with the Lenard, he will perform this experiment. So the experimental setup is, you can see the experimental setup. So the experimental setup is, when a potential difference is applied. So here we need to consider one cathode surface. And this is the voltmeter which is connected here. It is connected to the battery also. It is connected to the battery. Here it is connected to microammeter. This is cathode. And here there will be anode. Okay, so this cathode and anode, it is enclosed in one evacuated chamber. Okay, it is enclosed in an evacuated chamber. So here there will be a small gap that the light radiations will incident and it will hit the cathode surface. So when it will hit the cathode surface, the electrons will comes out. So later you can go through the figure in the notes. So this is the UV radiations which is incidenting. Here this is the window opening anta helbodu. Okay. So this is a glass tube we have here. C is the cathode, A is the anode, or you can also call it as what? C as the emitter. C is called as the emitter. And this A is called as what? Anode, or it is also called as the collector. It is also called as the collector. So how the photoelectric effect is observed in this one? See. So Leonard will do this setup, students. So when a potential difference is applied across the emitter plate and the collector, no current flows in the circuit. So first ನಾವಿಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಅಂದ್ರೆ we will connect to the potential difference. Okay, so first we will connect it to the potential difference. Then that time we will not observe any current. Next what we will do? Next we will expose this cathode. ಇದೇನ್ cathode surface ಇದೆ ಅಲ್ಲಿ, ಈ cathode surface ಅನ್ನ radiations ಗೆ, okay, we expose it for the UV rays. So ಯಾವಾಗ UV rays ಬಂದ್ ಇದಕ್ಕೆ hit ಮಾಡತ್ತೆ, when it will hit the collector plate, here what happens, the electrons will comes out of the surface. So electrons baratte, electrons bandu, it will come near the anode. So it will come near the anode, and that time we can read the microammeter reading here. So what is the meaning of the experiment here? When the light radiations falls on the metal surface, here the electrons are coming out of the surface which will hit the anode. So when there is a motion of the electrons from one point to other point, there is a current. There will be the current we can see. So this is the Lenard's experimental setup anta helbodu. So in the Lenard's experimental setup, we have one evacuated chamber. So for this evacuated chamber, inside we have the cathode and the anode. And this is connected to the voltmeter and the ammeter, and it is connected to the battery. So initially when you connect to the potential difference, there is no current. But yavaga light radiations incident agatte cathode mele, the electrons will comes out of the surface. So when the electrons will comes out of the surface, it will hit the anode plate and the collector plate hatra baratte. So when it will come to the collector plate, the microammeter, the current can be measured by using the microammeters anta helbodu. This is Lenard's experimental setup. Okay. So this is Lenard's experimental setup, or you can also call the experiment to study the photoelectric effect anta kuda helbodu. So idrinda namge enen conclusion sigatte nodana students. So what are the conclusion of this experiment? So see, ಇಲ್ಲಿ ಏನೇನ್ ಕನ್ಕ್ಲೂಷನ್ ಇದೆ ಅಂತ ಅಂದ್ರೆ, ದ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಇಸ್ ಅನ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಇದೇನ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಅನ್ನ ನೋಡಿದ್ರಿ ನೀವೀಗ, ಇಟ್ ಇಸ್ ಅನ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್. ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್ ಅಂದ್ರೆ ಲೈಟ್ ಬಂದ್ ಹಿಟ್ ಆಗ್ತಾ ಇದೆ, ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಕಮಿಂಗ್ ಔಟ್ ಆಫ್ ದ ಸರ್ಫೇಸ್. ಸೊ ಇಟ್ ಇಸ್ ಅನ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಅಂದ್ರೆ ಇಮಿಡಿಯೇಟ್ ಪ್ರೊಸೆಸ್ ಇದೆ ಅಂತ ಗೊತ್ತಾಗತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಫಸ್ಟ್ ಪಾಯಿಂಟ್. The photoelectric effect is an instantaneous process. Next, for a given material, photo emission takes place above certain minimum frequency of incident radiation. So that minimum frequency lane bekagatte for the phenomena that is called as the threshold frequency. So lane agatte andre students, for this particular phenomena we require some minimum frequency, and that minimum frequency is called as what? Threshold frequency anta heltivi. Okay. Third point, so above this threshold frequency, above the threshold frequency, the photoelectric current is directly proportional to the intensity. It is directly proportional to the intensity of incident radiation. It is directly proportional to the intensity of incident radiation. ಯಾವಾಗ above threshold frequency ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So 3 points. First one, photoelectric effect is an instantaneous process. Second point, so photoelectric effect ಆಗ್ಬೇಕಾದ್ರೆ some minimum frequency is required for the phenomena that is called as the threshold frequency. So above that threshold frequency, students, the photoelectric current is directly proportional to the intensity of the incident radiation. Okay. The fourth point. So the fourth point, again, it is what? That is above the threshold frequency, the maximum kinetic energy. The maximum kinetic energy of the photoelectrons, it is directly proportional to the frequency. So again, above the threshold frequency, The kinetic energy is directly proportional to the frequency of the incident radiation. Directly proportional to frequency of the incident radiation. Okay. The fifth point, the last point, the photoelectric current becomes zero. So photoelectric current enittala, idu zero agate. Yavaga? At a particular negative potential. So illondu potential kodtivi for the metal surface. Avaga ಏನಾಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ, for that negative potential, the photoelectric current becomes zero. Our negative potential ige ನಾವು stopping potential anta ಕರಿತೀವಿ. That potential is called as what? Stopping potential. These are the 5 points regarding the experimental study of the photoelectric effect. So see, what is the first point, students? Photoelectric effect is instantaneous process. It is an instantaneous process. So here we require some minimum frequency for the phenomena, that is called as the threshold frequency. Third point in ಹೇಳುತ್ತೆ, above threshold frequency, intensity is directly proportional to what? Intensity. Photocurrent is directly proportional to intensity of the incident radiation. So again, fourth point is, above the threshold frequency, the kinetic energy is directly proportional to the frequency of the incident radiation. The fifth point is, photoelectric current zero agatte for some negative potential. A negative potential ige stopping potential anta karitivi. So these are the 5 points regarding the photoelectric effect. If any doubt is there, please ask. Yes. So here some graphs we are discussing, students. You can make a note of this. Suppose if you plot a graph between photoelectric current versus the intensity of incident radiation. Okay. So the graph is a straight line passing through the origin. So idradha artha enu, the photoelectric current and intensity of light both are directly proportional to each other anta agatte. Suppose if you plot the frequency versus the kinetic energy, the graph will be a straight line, but it is from this point. So idra artha enanta andre, so modle enidalla, that is frequency, threshold frequency reach aguvarige there is no kinetic energy, correct? Yeah. So once you reach the threshold frequency, above the threshold frequency enagta ide, the frequency is directly proportional to kinetic energy. Getting? So suppose if you consider two metal surface, the graph you can show it like this. This is for the one surface and this is for the second surface anta navilli helbodu, correct? So ಇಲ್ಲಿ ನಾವು ಒಂದು ಡೆಫಿನೇಷನ್ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, that is the stopping potential. So stopping potential ಅಂದ್ರೆ ಏನು? It is the some negative, minimum negative potential when the photoelectric current becomes zero. That potential is called as what? Stopping potential ಅಂತ ಹೇಳ್ತೀವಿ. So in that case, ಆವಾಗ ನೀವೇನಾದ್ರೂ graph plot ಮಾಡಿದ್ರೆ for the stopping potential and the photoelectric current. So the nature of the graph, you can see it somewhat like this. So this is the potential agatte. This is photoelectric current. This is photoelectric current. So from here you can show it. So this is for the high intensity. This is for the low intensity. High intensity, low intensity. So then he'll point it there. This is the stopping potential. This is the stopping potential. Okay. So stopping potential is what? It is the potential at which the photoelectric current, and you will note both. This is the current axis. So current value ಏನಿದೆ, the current value is becoming 0. So ಇಲ್ಲಿ ಇದು second quadrant ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ potential value ಏನಿರುತ್ತೆ, negative ಇರುತ್ತೆ. So some negative potential for which the photoelectric current is 0, that is called as what? Stopping potential. Yes. So here you remember the stopping potential is depending on the frequency, does not depend on the intensity of the incident radiation. anta navilli helbodu. The stopping potential not depending on the intensity of the incident radiation. Okay. So it depends only on the frequency. So this is regarding the stopping potential, experimental observation of the photoelectric effect. Last one formula we are discussing for the stopping potential, and we will continue in the next class. So see here, the potential is equal to what we are writing, students? Work done per unit charge. So ಇಲ್ಲಿ potential ನಮಗೆ ಗೊತ್ತಿದೆ, potential is given by what? Work done per unit charge. But ಇಲ್ಲಿ potential ಇದೆ, it is the stopping potential. It is the stopping potential. And the work done, we can take it as the kinetic energy, and the charge is the electron. So here it is the stopping potential, Vs anta barkolana. So therefore Vs is equal to kinetic energy divided by E, or we can also write it as what? 1 by 2 me square, half mv square into E. Yes. So E is the charge of the electron, m is the mass, V is the velocity, velocity in the move ಆಗ್ತಾ ಇದೆ, and Vs is the stopping potential. So just to remember, Vs is equal to kinetic energy divided by charge of the electron. Okay. So in the next class, what we are going to do? We are going to discuss with the next point, Einstein's relation. So today we have discussed some 9 to 10 definitions and the experimental Hertz and the Lennard experimental setup for the photoelectric effect. So other than conclusion ide anta kuda discuss madidvi. In the next class we are discussing about the Einstein's relation. Okay. So if you have any doubts, you can ask. Otherwise we will meet in the next class.